Okay. Number 6. This is what we did last time. We finished here. But do you remember this one? This is if A happened. You know A happened already. What's the chance for B to happen? What's the probability for B to happen?
The intersection of
Yeah. Yeah, we're talking about, yes, the reason we talk about, this is another place to talk about probability anyway, because probability is next year. However, this is sort of a probability, yeah, it is kind of intersection. That's why we talk about it here. This is A, this is B, right?
Yeah.
Last time we said, let's just say, this is, assuming, let's talk about people, right? The people, you distribute the people in there evenly. So the people, number of people is proportional to the area. And now, this is you can't say nice guys and bad guys. This is the people with good grades. This is nice people. You know, there are nice people, they get good grades, and nice people, they don't. And there's a intersection here.
Yeah.
Right? So you're saying, for instance, let's say this is nice people. This is nice people. This is people who get A's, right?
Yeah.
Well, I probably should do the other because this is A already. Let's just say this is the people who get A's. This is nice people. Okay? Now, you want to know, assuming this person already got A's,
Yeah.
what's the chance for him to be nice?
That intersection thing.
Right. This is this. So it's this dark area in this proportional to this A. And then how many people who got A's is in this dark area, right? So what you do it, the way to do it is the A intersection of B. This is this dark area, right?
Yeah.
The area of this dark area. And then divided by the area of A, right? That's probability. I just want to, there is a point that I do this not only for this. I want to just to go one more step beyond this. Since we have this, right? We just copy, multiply this over. So it's A intersection with B, right? A. Right? You multiply this over, that becomes right? Does this make sense? Let's just multiply it over, right?
Nope.
Oh, you multiply this up.
Oh.
You move this up, then it's like, let's just move a little bit.
Okay.
Yeah. Now, you see this? This will equal to, because A and B, A intersection of B equals to B intersection A, right? It's the same thing. So you can write it this way. Right?
Yeah.
This is assuming B already happened for the chance for A to happen.
Yeah.
In other words, this person is nice. And what's the chance for him to get A or whatever, right? You multiply by the chance for this person to be in this B.
Okay.
Yeah? And we move one step more. We divide this PA over, down. Now, we get this. In other words, this is the sort of a trick that they used in sort of like a math competition type of things. They make it so hard for you to. They want you to find out what's the chance for a nice person to get an A. But they set it in a way there's no way for you to find it. However, for a person who already got A to be nice, they make it very nice, easy to find. And also, you know the chance for A and B to happen.
Yeah.
And this is kind of a formula. This is tricks, because this is not the place we're gonna do statistics. So so we're not gonna get into this anymore than this. Okay. Now let's go over this thing. So now we know set, right? We're kind of doing a review. We're doing sets, right? So let's say, I look my nose. That's cheating. If you know A, then B. You know this, right? You have A, you have a B, right? If you know you have a B, then you have C, right?
Okay.
Can you say, from these two, can you say, if you know A, then you know C? Can you say this?
Yeah.
You can, right? It's obvious, right? If John is a king, right? This is John is king, right? Then you know John is a man, right? This is the man, right? Let's say if the man, they all belong to persons, right? Right? This is man, this is persons, right?
Yeah.
Then John is definitely a person, right? Obvious, right? So now let's say Leo is a boy, right?
Yeah.
And then all boys are bad. Then you get Leo is bad, for instance, right?
Yeah.
But that's not true, right?
Yes.
Okay, it's true. Let's say John, right? You don't think all boys are bad, right? Well, anyway, I'm this. Okay, let's say John is good, right?
Yeah.
But then let's say you also believe all boys are bad. Then John is bad, right?
Yeah.
But that you got it from this. This logic is good. But then the problem is the thing you put in is bad. So when you look at these logic, this is sort of a general comment about mathematics. You ever heard of a garbage in, garbage out?
No.
The math could be good, but if you put in, math is like a process, right? You put something in, then something come out, right? You put in, say, Leo is a boy and all boys are bad. So you come out, Leo is bad, right? If you put in garbage, you're going to get out garbage. But the logic is correct. The logic has no problem. The problem is all boys are bad. That's the problem. There are some that are good. Theoretically, anyway, right?
Yeah.
Okay. That is, we just study the numbers, the set, and whatever, all of these things. That's number one. And all of these numbers, they interact together. Adding, multiplying, and then let's do this. We do the 3 plus 2, right? 3 minus 2, 3 multiply 2. This minus is the same thing, right? 3 divided 2, no. And then 3 to the power 2, right? And then log 3, right? I also have sine 3. We talked about that, right? Sine 3.14 equals to what?
A circle.
Huh? No. Sine is a number. What's 3.14? That's what kind of an angle is that?
360. Like an angle.
3.14.
Wait, no, never mind.
what angle is 3.14?
Super small angle.
No, that's 0. 3.14 is a pi, right?
Yeah.
Yeah. What's the angle of pi correspond to?
360.
When you have when you draw a circle, right? This is the radius is 1. What's the length of the whole thing? 360, right? What's the length of this circumference of this circle?
2 pi.
2 pi, right? Are we talking about 2 pi here?
No.
So what's this angle? 3.14 is correspond to what angle?
It's not.
What's that?
3.14 doesn't represent. Wait, so 3.14 is the angle, so it's a supersonic angle.
No. This is radius, not degrees.
Yeah.
The radius is the length of this. You have an angle, right? The length of this corresponds to the angle, right? So if you 360, this length all the way around is 2 pi, right?
Mm-hmm.
Is 2 pi is 6.28. The whole thing is 6.28, right? The whole circle.
Yeah.
No, I'm saying that the angle is just 1 pi. So how big the angle is?
360.
No. When it's 360, right? The angle is all the way around.
Oh, 180.
180, right? Okay.
Yeah.
What's sine 180?
Um, 90.
180 degrees. What's the sine? When you have a point in here, right?
Yeah.
What is sine anyway?
The
Which one? Do they call this x, call this y, right? Sine is x or y?
Y.
Y, right? Y divided by 1 is all y, right?
Yeah.
So this is the angle, by the way, right? So 180, what's y? What is y at this point?
Just Y.
No. What's the number y? Yeah, at this point, what's the number y? At this point, what's y? What's this point anyway? What's coordinate of this? Every point you have an x, y, right? Right?
Mm-hmm.
What's the x, y at this point? X equal to what?
X.
At this point, x equal to what? I know this is the 1. This is just drawing the 1. The radius is 1. In other words, let's put it this way.
The square root of a squared plus.
No. When you have a point, right?
Mm-hmm.
You say this point has an x and a y. What is the x and what is the y?
X is just.
X is from where to where?
It's the horizontal one.
Okay, from here to here, right?
Yeah.
What's y?
The vertical one.
Yeah, from here to here, right?
Yeah.
Yeah, now the point is here.
Mhm.
And the length of this is 1, right? We're drawing a circle 1. From this point to every point is 1, right? So what's the coordinates here? What's x, y here?
Well, it can't be 1.
Why not?
Because C is 1.
Yeah, at this time C is so to speak B. C and B. When this angle, right? You're talking about this, right? You're talking about this is B, right? This is C, right?
What is
Oh no, A. Sorry about that. This is alpha, right? Right. When this angle is all the way down, then the B and C is the same
is that
thing.
X? Y?
Huh? This is A. I'm talking about this. I'm going through this symbol. Yeah, this is Y. This is X in our case. In this case, and this is the 1 in our case. You said this cannot be X cannot be 1, right?
Yeah.
Because there's always a Y, right? Yeah, that's what you're thinking. However, if this point all the way down, right?
Mm-hmm.
There's a C and B is the same thing, and Y is just 0, nothing. This point goes all the way down into this. Yeah.
Okay.
In that case, what's X and Y? The point is right here.
1 and 1.
1 and 1. Right? So X, this measurement is 1, right? is y.
Is y 0.
Y is 0, right? Good. Y is 0, right? Let's get this first. So what's the coordinate of this point?
1 negative 1 0.
Yeah. So in other words, you know sine pi is y. What's y?
One. Wait, 0.
Cosine pi is what?
One.
No, here.
Negative 1.
All right. Now you just said a very, very important thing. You point out some very important thing that which is going on, which is screwing your head. Is what if this point approaches this point, right? And then the y is going whichever direction and stuff. That kind of thing start happening. Yeah, because those two are too close. However, when you look at this approaching, right? When you're really approaching at the tangent line is up straight up and down, right? So in the very last moment, when it's infinitely close to this point, all this point doing is come straight down. On the very last moment, we're talking about infinitely small segment. The infinitely small segment is going straight up and down.
Okay.
Yeah. So in other words, b equals to c and y equals to an infinitely small number at that point.
Yeah.
And also like to exaggerate a little bit, it comes down this way. This is a right angle. This is a right angle. This is infinitely small. We'll call it dy. And this is the x. This is the r.
Okay.
Yeah. And this is an approximation, obviously. If this is a right angle, this is a right angle. What's this angle? Zero. Yeah, you said it. Yeah, but it can't be 0. But it's approaching 0, right? So this is off by a little bit. We're talking about little bit, right? This is very important later on. This is when we're talking about calculus. This is what we're talking about. Very infinitely small things. Calculus is to study the infinitely small things, small change, and integral is to add it back up. All right. Now we know this, and also this is the second thing. When you look at math, you look at a set, which is, let's just say, some numbers, and then you look at these numbers. They add whatever, they do kind of things. You can sign a number, 3.14, whatever it is, right? And then you do this, y equals to fx. We said in a more general form is fxy equal to 0, but we just don't worry about that. We just look at y equals to fx.
Okay.
We study things. We for instance, every year, every year we want to know how much money we make, stuff like that, because that's too many elements, too many factors impacting the answer. So it's very hard to so from a pure mathematical point to figure out. But there are simple things we can figure it out. This is most of the time we're gonna deal with this. You put in the x, you get a y.
Okay.
Yeah, and you want to know y corresponding, like what time what an object is, and let's say you invest, and after so many years, every year you get 6%. After so many years, how much money you have, stuff like that. Okay. This is what we did last time. This is just to understand the nature of things. Yeah. Okay. Bye bye.